Okay, we're looking at the limit of x over sine x as x approaches 0. I'm claiming that it's equal to 1. So we do the direct substitution, plugging 0 directly in for x, and we end up with 0 over 0. Remember that the sine of 0 is equal to 0. Well, that means that we're going to have to do something to this. Now, in some previous problems, we've seen this, and we took this for granted. This was fact, that the limit of sine x over x as x approaches 0 is equal to 1. And we're going to use that to show that our limit is equal to 1. Okay, so this is our limit, x over sine x as x approaches 0. Now what the trick I'm going to do here is I'm going to write 1 over sine x over x. Now you kind of see the trick. When you simplify this down, we just end up with this, right? But by properties of limits, we can take the limit of the numerator and then the limit of the denominator separately. And the limit of a constant, or the limit of 1 as x approaches 0, is just 1. And remember, this was the fact that we were using here, that the limit of sine x over x as x approaches 0, that this is equal to 1. Therefore, our limit is equal to 1. Okay, we've got the limit of the sine of 2x over sine of 3x as x approaches 0 is equal to 2/3. Now we do the direct substitution, plugging 0 directly in for x, and we end up with sine of 0 is equal to 0, and the sine of 0 in the denominator is also equal to 0. So we're going to need to do something with this. Now here's the trick, at least I call it trick. What I'm going to do here is I'm going to write an x over x, a 2 over 2, and then a 3 over 3. And these 2's are coming from, the hint here is because there's a 2 here, we're writing 2 over 2, and because there's a 3 here, we're writing 3 over 3. Now we're going to do a little switcheroo on this, and we're going to switch some things around. So I'm going to take this 2 out front, gather these two terms here, this x and this 3x together, and then I just rewrite the sine of 2x here. And then down here in the denominator, we're going to pull this 3 out here, and then I'm going to write this sine of 3x down here, and I'm going to take this 2 and this x and write it under here. So now it's in a form where we can break this up and now take the limit. Okay, so by the properties of limits, we can break this up into 3 separate limits. So we've got the limit of 2/3 as x approaches 0 times the limit of 3x over sine of 3x, and as x approaches 0, I should say, and the limit of sine 2x over 2x, x approaches 0. Now the limit of a constant is just the constant times this 1. Now in the previous problem, which we showed that right, this 3x and this 3x here are going to end up being the same number, and we showed that this was equal to 1. Regardless if this is a 3, 4, 5, or any number, as long as that same number is down here also, and as x approaches 0. So this is equal to 1. And the same thing here, this was something that we just took as fact, that the limit of sine of 2x over 2x as x approaches 0 is all equal to 1 also. Now remember that if there's a 2 here, there has to be a 2 written here also. So whatever this number is, that same number's got to be written here. And the whole thing will be equal to 1 as long as x approaches 0. But anyway, after doing the evaluation or the arithmetic here, we end up with 2/3, and that's what I had claimed that our limit was equal to.